All right, just a few example problems from 3.2. So for each of the exercises, it says find the measure of angle 1 and the measure of angle 2. Tell which theorem you could use in each case. So depending on the order that you find the angles in, if you find them in order, then really everyone should be using the same theorems. But if you find them in a different order, you might use different theorems. For example, on number 1, so I'm given that these two lines are parallel. I'm going to label them L and M, and then this is the transversal T, so you know which lines I'm talking about. Say I want to find things in order. Angle 1, this 110 degree obtuse angle is given. If I find the measure of angle 1 first, here's how I would write it. Here's how you should be writing it as well. The measure of angle 1 is equal to, and then these two angles are alternate interior angles. These two lines are parallel, cut by a transversal, so the alternate interior angles should be congruent. The measure of angle 1 is 110 degrees. Again, that's the alternate interior angles theorem. And then on angle 2, depends on what angle you use. If I use the 110 degree angle, then 110 degrees and the angle 2 are corresponding angles. So those two angles should be congruent. Angle 2 is 110 degrees. Again, I could use the corresponding angles theorem. That's not the only theorem that you could use. Corresponding angles theorem is one theorem that you can use. The other theorem that you could use is if I have the measure of angle 1 first, 110 degrees by the alternate interior angles theorem, then the measure of angle 2 is equal to the measure of angle 1 by the vertical angles theorem. So you could use either. Just depends on what you use specifically to find the measure of angle 2. Okay, and then some of these I'm going to go through kind of quick, or I might skip example 3. But example 2, again, if I find the measure of angle 1 first, and I use the 63 degree angle, again, these two lines are parallel. Let's just call them L and M, even though they're not labeled. And then I'm going to make this line the transversal T. Okay? But if I find the measure of angle 1 first, it's corresponding with the 63 degree angle, so those angles should be congruent. Again, it's written like this. The measure of angle 1 is 63 degrees, corresponding angles theorem. And then for the measure of angle 2, if you use the measure of angle 1, angle 2 is a linear pair with angle 1, so it should be supplementary with the 63 degree angle. 180 minus 63, 117 degrees. I could also use a 63 degree angle, and then to find the measure of angle 2, these two are same side interior or consecutive interior, so they're still supplementary. Angle 2 is supplementary with the 63 degree angle, 180 minus 63, still 117 degrees. So the measure of angle 2 is 117 degrees. Again, I could use the linear pair theorem, or I could use the consecutive interior angles theorem. On this last example, I'm just going to go through it orally. If I find the measure of angle 1 first, again, these two lines are parallel. Here's your transversal. To use the 95 degree angle, these two are vertical angles. So the measure of angle 1 should be equal to this 95 degree angle. So measure of angle 1 is 95 degrees, specifically by the vertical angles theorem. And then if you use angle 1 to find the measure of angle 2, those are the alternate exterior angles. They're congruent, 95 degrees. I could use this 95 degree angle to find the measure of angle 2. It's still 95 degrees, but these two are corresponding angles. So again, depending on what angle you use, depends on what theorem, not the angle measure, but the theorems could be different. And then the last example, or examples that I could use, now we're just given the angles in terms of algebraic expressions. So to find the measure of the algebraic, or to find the value of x, I could set up an equation specifically using one of the theorems, like on example 5. On example 5, this angle x plus 12 is alternate exterior with 110 degrees, so they're still congruent or have the same measure because these two lines are parallel, but I would just set up the equation x plus 12 is equal to 110, and then just solve that by subtracting 12 from each side. Then x is equal to 98. And You could double check by substituting in 98 into this expression. 98 plus 12, 110, those two angles are congruent. Okay. Example 6, these are alternate interior angles. They should be congruent. So 45 is equal to 10x minus 55. You solve that using your inverse operations, add 55 to each side, and divide by 10. Okay, so just use the theorems. For most of the theorems, 3 out of the 4 theorems, the angles are congruent. If we're just talking about the theorems from 3.2, and then it's only consecutive interior angles that are supplementary from theorem 3. From the theorems from 3.2. The theorems from 3.2 don't actually include the linear pair theorem, but that still holds true.